Hello everybody, my name is Ivan Blaškić and I'll be presenting on the steps that I have completed while building up my compiler. I've completed 74 steps and I got to the point where I have to actually implement the optimizer for R2 language, and I wrote some tests for it, but I didn't actually implement it, so I know how is my grade gonna depend on that, but never mind. So in order to actually make this possible, what I needed to do is to add type checking, to add additional type, which is boolean, in comparison to what we had in R0, which was just integer. And then I had to add some commands that are dealing specifically with bools or can deal with bools, and those are comparison and ifs, and I added also not for booleans, yeah. And then yeah, so that was kind of it. My biggest challenge in doing this was dealing with having a new type, and like everything that like it matters actually what you're like sending, what you're like expecting to get out of the specific expression call. And there's like you just have to be extra how can I say, you have to be extra careful with how are you actually dealing with types in your code, in your program. And yeah, so some challenges for me in regards to this. The most challenging part for me was maybe just like the last step, like managing to have your to have your program generate random programs, because what helped me a lot, I just implemented a little portion of a code outside of the big code that I have, and I played around with extending the data structures, and extending the stuff that I already had for R0, and then it was easy, like having just a simple little code and testing everything out, and like memory management and everything. It was easy after doing that. It was easy to actually make use of it and just add it to the bigger picture and to the bigger code. So this was kind of trivial. I'm gonna run my code, compile it and run it with this this button here. And I had some problems with this because I'm doing the so yeah, this is the code that was generated. If I press continue, if I press enter, it's gonna generate more codes. Here it's kind of obvious what this code does. So I'm not gonna go over it in the details, but just realize how important it is that I let here that it knows that x is assigned an integer value, and then that it knows that if here knows that this is, this is obviously that this is, say, integer value, right? Because it's read is being done. So there's like extra bit of information going around the code, and we need to take care of it and manage it properly. So that was the hardest kind of thing, but I didn't find this actually very interesting and cool. So yeah, I'm gonna move on the steps that I took previously, and that's gonna be explained in a second. So let me just open the new command prompt. You would assume that I was ready for this before, but I have to do this while I'm running the recording for the weird reasons that I'm not actually aware of, so I had to remember this. But yeah, once while I'm typing this, what I had to do is to manage to actually assign registers properly. So in order to do that, we had to deal with we have to understand when is what needed, what variable is actually needed at what point, and then going from there, we actually decided that maybe in some cases we can be extra smart, and then we can just uh, play around. So we can the whole idea actually is to have like registers for one register for multiple of variables, but then on the other hand there's on top of that we can also just like use we can also get rid of some instructions just by uh, doing move biasing and like assign like uh, yeah, just like I got confused for a little second, sorry, but yeah, with move biasing, with move graph, we are gonna keep track of, for example, if t is moved to v, we're gonna keep track of that in move biasing, and then we can actually avoid even like using that instruction because we don't have to move t to v anymore, and that's gonna be one instruction less in the final version of the code because it's actually already there, you know. So yeah, those little things, little tricks, and they're kind of fun. And as you're gonna see now, uh, this is how it looks like. So let me just check if I did this right. Yes, that's where we have to go from here. And then what I want to do is compile my, which I think is not even necessary, but let's do it just for the sake of it. Compiler one.cp. So what I did, I just like have different like I have the old version of the code and the new version of the code just so I can show it to you kind of what I've done and how I did it. So yeah, I compiled the code. There's some warnings, we are gonna ignore them like all good programmers do. Just kidding. So yeah, so here, so this is our code. I'm gonna try to do this. Yeah, it's fine. So this is our code, and this is the execution in R0 language, which is initial language we start our that we start translating from, let's say, compiling from. And then we have the same code but with unique variable names, but this is all boring and we already went through that. So here is program execution in C0 language, and things are gonna get interesting soon. So yeah, this is in again in X0 language. This is in X0 language. And then now, as we saw, we have some variables, and here is what is live at what point. So this is like 9 lines number, and then this is what is actually live at those points. And as we move along, you're gonna see how we're gonna see how we're gonna deal with this, right? So here we see what's interfering with what and in what lines. It's denoted on the left what line. We keep track of everything, and then we are just like for each variable we are like realizing what's it interfering with. So this was important for me. I got like in problems with this because I didn't actually like this should be a graph usually. So my data structure that was like kinda being a graph wasn't really being a graph. So this was the one that I actually had to use in order to make this work properly, right? So each variable actually knows what is it interfering with. So yeah, so now what is going on is that here we see like that. Give me a second. Yeah, so here we see move graph. Move graph is just like what is moved into what. So this is gonna be useful. And here we see that there's no actually none of the variables actually cannot be something, you know. So that's gonna change eventually. So for now, like we can just take any of them and assign any of registers to it because there's no real real interferences yet. So yeah, and this is how it got updated. So yeah, let's make it more fun. So yeah, the one that was interfering with the most things, we assign it to 0, which is like which is gonna be eventually register RBX, I guess. And then we go on. So we see now that like, saturation was increased by 1 to all of those that actually interfere with it. And then we go on and we assign another, like we just colored another variable, and it doesn't interfere with anything from the list here, so nothing changed actually here in saturation. So we move on, and then first time here there's something that is saturated, like that has saturation 2, so it interferes with, let's say, 2 registers already assigned, so it needs a new thing. And then doing that, like just that process results in something like this. So here I use the RX, just know that eventually that's gonna change because our return value is gonna be there. So yeah, for the sake of testing this, it doesn't even really matter, but eventually it's gonna really matter. So gotta be careful with that. And this is all stuff that we already have seen in my first presentation. It works. We know that it works. It's not using variables here. There's some extra lines that I could delete, but I just didn't go. I wasn't too much into it. I tried to get other things done, but this can actually look better, more appropriate. But yeah, value that is the result, and it's in RAX is going to be 15. The last value in RAX, and then another interesting thing that I've done, except for actually coloring this thing and not having variables here, is going to be this. This is so actually hard for me to do, so I did it. So here, what we just saw was my program just have put all of the stuff from my, like it just generated my assembly code and then just like transferred it, like sent it with OStream output stream, right? Probably through the pipe, I'm not even sure, but yeah, it just sent it in a way to the file .asm file that actually got compiled in and then along with the main code, which actually tests it and checks what's gonna be the return value of it, and then that value is gonna be written in the text file, which I'm going to read from, and I'm gonna, if the value in text file matches the value that I got from running R0, which we know that it's correct, it was tested already, then the appropriate message is gonna be sent to the screen. Here, this CMD that just opened is just main.exe being run, which just is there to just run, so it actually something gets written into that file, .text file. So cool. Moving on, we are soon gonna see close to the end, and we are gonna soon see. So yeah, generated assembly code produces the correct result. So if we look in my code, which we are not gonna do now because it's a time waster right now, we will see that it was actually compared, and the string was the consequence of having my compiler work nice. Okay, so that's all I got for you. I hope this all makes sense, and I hope you enjoyed. I wish you have a great day, and yeah, that's it. Bye.